this video, we're going to go over the pros and cons of decision trees. One of the reasons why I really like this topic, this slide, this video, is because I think it sums up the entire course in just a few sentences or bullet points. So in blue, we'll have the pros, in red, we'll have the cons of using decision trees. I think by far the biggest pro for decision trees is that there are absolutely no assumptions. We don't have to spend any time asking questions about whether this is the right problem to use it for. We can just use it and see if it performs well. Sometimes they give us better prediction than our other models. They can predict continuous things, binary things, and anything in between. Any problem you have, we can use a decision tree to make predictions for, and the question will only be how good is the tree at doing this job. It has built-in stepwise selection, so we don't have to think about which variables do we want to include. We saw in one of our examples that it didn't include age, which I was actually surprised to see. It will choose at every phase the best possible split, so it's doing those things one step at a time. Another important pro of decision trees is that there's zero pre-processing. And what I mean by that is I don't have to think about in baseball, is runs allowed and runs scored best represented in a ratio? Or should I create an interaction term? I don't have to think about what I pass to the model. I just have to give it all the information it might need, and it'll create interaction terms and nonlinear terms without my intervention. When I was doing a project that I've mentioned before, predicting short-term price movements in the stock market, I discovered in my decision tree that when I actually tried to do more thinking about what data I gave to the tree, creating interactions and ratios of things that I would normally create ratios for, the tree did worse. So what I think is really neat about decision trees is that there's none of that. So why would I ever use anything else? Why don't we focus in the entire class on decision trees instead of wasting our time with all of these other things that have assumptions and require us to consider stepwise selection, consider interaction terms? Well, it's because there's a really long list of cons associated with decision trees. And the first and most important from my perspective is that it's a black box. It's not easy to make inferences in the way that we normally can look at a hypothesis test and determine which variables are significant. We can't do that. We also don't get coefficients. So we don't know, hey, for every time we increase age, by 1 year on average, we'll see this effect. It just doesn't exist. So if your goal is to understand relationships, if you're studying childhood diabetes and hereditary influences on that, there's going to be no ability to take away. There are some things we can do to try to take things away from decision trees, but if you're looking to really understand a problem and extract those coefficients and average relationships, then a linear regression or a logistic regression is going to give you those coefficients. So you have to decide, do I want to make good predictions? Or do I want to really understand something? So this is why I like this slide so much. This conversation about why decision trees are good and why they're bad brings us back to our linear regression models and logistic regression as well. There's no goodness of fit measure for a decision tree. There is something called node purity, which is trying to point at goodness of fit, but there's no R squared. Just like logistic regression, we have to use prediction accuracy. Even logistic regression does have some measures of fit, but in this case, there aren't any. We just have to use prediction accuracy as our best guess of how well it fits the data. In decision trees, overfitting is very, very common. There are ways around this, which we'll get to in a moment, but this is a common problem of decision trees. It'll continue to split and split and split when it might not need to. Finally, decision trees are unstable. Small changes in your training data could produce big changes in the tree. This can be addressed by something called boosting, which is at this point just good for you to be aware of, that there are ways to fix these problems, but we're not going to go any further about boosting or node purity in our class. Now, the user, as I've told you throughout class, the user holds the ultimate responsibility for deciding whether it's more important to understand the relationships or it's more important to predict, whether you're okay with testing assumptions or whether you need to go with something that doesn't have any assumptions and requirements. So it's really up to you to browse the pros and cons list and decide which model is best suited for your problem. So some conclusions about decision trees. They can be really helpful if data violates other model assumptions. So if your linear regression assumptions are violated, or if your logistic regression assumptions are violated, your next focus would be on decision trees potentially. They're only useful if we don't need to understand the relationships. We don't need coefficients, we just need to make great predictions. There are lots of options to make our decision trees better and better, but as we've discussed in the past, lots of choices often come with lots of responsibility in supporting why you've made your choice and communicating those results to your clients, your manager, your colleagues. But decision trees, the major reason why we would consider them is that they could help us improve our overall capability of predicting. Just a few important extensions of classification and regression trees that could help reduce overfitting are pruning, bagging, and something called random forest. And random forest is what I've used in the past. It's not just a single decision tree, but it's like creating at random many decision trees and averaging their results to give you a more robust prediction. And they tend to do a really good job, and they also eliminate the overfitting issue. But pruning and random forest are both very easy to do in R. And again, these are just extensions for you to be aware of. We're not going to talk about them in class. We'll talk about decision trees, and you'll be expected to know the pros and cons of those. But these are just extensions for you to be aware of if you ever find yourself using decision trees in your work life.